Hello YouTube. Today I wanted to talk about one of the most important parts of a radio, the tuned circuit. A while back I did a video about resonance. I suggest you watch that. But today we're going to show you the schematic here. We have an RF sweep generator and it puts an output out to control the scope's horizontal, and also puts out a varying frequency that's in sync with that ever-changing horizontal frequency that you put it into a tuned circuit. And then after your tuned circuit, you run it through an RF detector into the input of the vertical on the scope. So what this does is this actually shows you the resonance curve of a tuned circuit. That's what this setup is for. So yeah, over here's the generator. The tuned circuit is right here in front of you. The RF detector is this long brass tube. And we got the scope. And also up top I have a generator to show you how that plays a role in all of this. But right now on the oscilloscope you can see a curve. Let's get a little closer on that. That is the curve of the tuned circuit. And right now I'm going to turn the generator up. And you see what's happening there? Jumping around. The generator is putting out the frequency of, I should say, that's equal to that of the resonance of the tuned circuit. So as I change the frequency, you can see how that changes. So that's like a marker. We call it a marker. So if I know what frequency that is, it's about 20 megahertz is what this is tuned at. And you can see how as the generator, the on top generator approaches the resonance frequency of the coil to where it's tuned, you can see how it increases. Now if we put modulation on here, you can see what happens. See, as you reach resonance, the modulation is also showing on the resonance curve of the coil. Ain't that neat? And I don't even have the generator directly connected to this circuit. I just have the wire coming down and going near the coil. But yeah, that just goes to show you how you make a marker to know where you're really at in frequency. And as I said, the tuned circuit's down here. It's just a coil and two capacitors, two mica capacitors is what I'm using. I think they're called silver dip mica. And the generator, you can control the output of the generator. You see that's the RF output, so it just increases the size of the wave. And then you have your sweep width. I can make it quicker, or I could widen it. And then you gotta adjust the frequency a little bit when you do that. But yeah, let me put the marker on again. You'll probably be able to see it better. There it is. See it? Let me take the modulation off. Yeah, there's the marker. You can see how it climbs up the wave and then back down again. And like I said, this is the most important part of a radio, the tuned circuit. So this equipment here is basically telling you how to align the tuned circuits. There's all kinds of tuned circuits in a radio. There's what they call the IF frequencies, which stands for intermediate frequencies. Some really good radios have a first stage RF amplifier. So you have RF, you have IF. And you also have a mixer or a local oscillator frequency. And all of that combines together to make a radio. But as I said, tuned circuits, this is one thing that's never going to go away. You always have to have a tuned circuit in the radio. And you're saying, well, why do you have to have a tuned circuit? Well, that's a really good question. But the true answer is if you don't have a way to select a certain frequency that you're receiving, you'll receive all of them. Imagine turning a radio on and getting 5 to 10 stations at one time. That's what would happen if a radio did not have a tuned circuit, a way to select a given frequency. So that's why you have to have tuning. Tuning is very important. So I hope you enjoyed this video. I really did want to do this one for a long time now, to show you how a resonance curve actually looks on an oscilloscope, using a generator and related parts and stuff. But yeah, that's it. And like I said, there's the circuit. Go down a little bit. It's just a coil, in and out capacitor. I said there's my homemade RF detector. That's just 2 diodes in there, a capacitor and a resistor. That's all that's inside there. And that's how it works. And one other note, touching any part of the circuit, you can see how it changes. Oh yeah, there was one more thing I almost forgot to show you guys. Remember I talked about harmonics when I did my video on tuned circuits, or I'm sorry, resonance of a coil. There are harmonics on this too. There we go, right there. I just lowered the generator's frequency, and let me take the output up. You can see the markers there too. That's the harmonic frequency, or half of its normal resonance frequency. See how it shows up? And the marker shows up there as well. That's half the coil's resonance frequency on the generator. But here's the true resonance frequency right there. Let me turn the output back down. So that's what happens with harmonics. You have your true frequency, and you have your harmonic frequency. But now, in this case, there won't be an upper harmonic. If I go up in frequency, there won't be an upper harmonic. It'll only be half of the original frequency will start to resonate the coil. And like I said, there's a natural frequency, or natural resonance of the coil. And this is the sweep width control. You can control how wide or how narrow you want it. And I said that you can see the marker there. And let's put modulation on it one more time, just to show you how neat that is. So if that was a radio station, you would be here. And you connected an audio amplifier to there, you'd be hearing the audio of whatever's going on right now. Pretty cool stuff, huh? Thanks for watching. Thanks for coming along. Please subscribe. And we'll see you all again later. Bye-bye.